Assalamu alaikum wa rahmatullah, and welcome to all of our beloved viewers to the Voice of the Cape's Facebook page and the Voice of the Cape's YouTube page. My name is Amir Adams, and I will be in your company now for today's Matric revision session, where we continue the Voice of the Cape's annual Matric revision sessions that is being sponsored this year by the Two Oceans Graduate Institute. As a reminder to all of our beloved viewers, that this is the Voice of the Cape's annual Matric revision program. And of course, this year, we'd like to encourage all of our beloved viewers to forward and share this link on the Matric revision sessions with your family members and all of those who are preparing for their Matric exams. As a reminder, this is being sponsored by the Two Oceans Graduate Institute, as I had said, which is an accredited online platform where you can become a primary or a high school teacher by studying in the privacy of your own home. And for more details, you may visit their website, www.togi.ac.za, or you may call them on 021 829 7015. For today's session, we have our esteemed facilitator, none other than our dear sister Zainab Afrika, who is here on behalf of Supreme Scholar, and she will be going through content of Physics Paper 1, in particular, doing electrostatics. She has already started on this topic, so this will be part 2 of electrostatics, dealing with content on Physics Paper 1. Inshallah, as a reminder, once again, please share and forward this link of this particular session to all of the students out there who are preparing for their NSC exams as well as their trial examinations, inshallah. And with that said, without further ado, we immediately hand over to our sister Zainab to conduct today's session on Physics Paper 1, inshallah.
Okay, shukran so much. Bismillahirrahmanirrahim. A'udhu billahi minash shaitanir rajim. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Okay, so today we are going to do electrostatics part 2. What I'm going to do is for the first 5 to 10 minutes, we are going to just do a quick recap based on what we spoke about. I said that we needed to split electrostatics into 2 parts because it's quite a heavy content, right? And in your physics paper, it weighs a lot of marks. And so I went through basically most of the theory last week. And so this week we are going to do a lot of calculations. So this session is going to be more of calculations and more of answering questions. So please get your books and your pens out, write down these examples, and these examples are provided with solutions, and use this as a baseline to solve all your other problems. Okay, the problems that I've given you in the session, or I'm going to give you in the session, is sort of going to be very similar to the rest of the questions you will probably get in your exam. And so probably different scenarios or different numbers, but the concept and the content is going to remain the same. So like I said, it's very important that you get your books and your pens out and you sit and you write down these questions, and so you have them as a baseline to sort of help you in your studies. Okay, so we are doing now electrostatics part 2. Tomorrow we are going to do the work energy theorem, hopefully, inshallah. So today we are going to conclude our electrostatics. So basically, just to recap quickly, the things that we have spoken about was we have spoken about Coulombs law, and I mentioned please know the definition. Okay, they're going to ask you define Coulombs law, and you must know it. Okay, we studied a little bit about electric fields and what does it mean if you want to determine an electrical field at a point. We studied lines, and we sort of a little bit studied on the principle of superposition. Okay, and so we spoke about charges are made up of protons and electrons. And so I'm going to elaborate on this more. What I'm going to do is I'm going to skip to the slide where we are going to start off today. And that slide encompasses everything that we have covered up until now. Okay, we get a little bit of a question. These are our activities. And then this is where we sort of ended off the session. So this is where we're going to start off today. Okay, so we spoke about Coulombs law. And let's say it again. Let's remind ourselves, what does Coulombs law state? That the electric force, okay, between two charges or at one charge with regards to another, okay, is directly proportional to the product of two charges and inversely proportional to its mass. Okay, here we go. Directly proportional, Q1 and Q2 product means multiplication, and inversely proportional to the square distance between their centers. The square distance, r, is the radius, and it's squared. So like I said, the formula sort of tells you everything that is needed in the definition, okay? We've unpacked this because we did a question on it. The force, obviously, magnitude, r is the distance, and q is the magnitude of the charges, okay? And so I didn't, the session, I did not sort of go through the graphs. Okay, I didn't go through the graphs. So today I just want to quickly show you, because it's very important that we understand how the graphs work, because we're going to do a little bit of multiple choice questions. You know, the first sections of your paper, those are always multiple choice. And I'm going to show you typical exam questions that they like asking when it comes to Coulomb's law. Okay, so we said that Coulomb's law says that the force is directly proportional to the product of its masses. Here's it. Okay, this is the definition graphically. Okay, directly means F is directly proportional to Q1 and Q2, and Q1 and Q2 are products of its masses. Okay, so it's a linear relationship. If the one increases, the other one will also decrease. And it's inversely proportional to the square distance between their centers, which means it must have a decline. Okay, it must have a decline. So the force, directly proportional straight line, and inversely proportional to the square distance between their centers. Okay, so that is something that I wanted us to just understand properly and visualize graphically, okay, because it's going to help us with the following questions to come up. Now, remember I said to you in the beginning, and I kind of didn't do a proper demonstration last week when we had the session, but how do we charge an object? Remember, everything in this universe has positive and negative electron, okay? Now, in order to induce a charge, you need to remove the neutrality, okay? Things are generally neutral, okay? Things are generally in equilibrium, okay? And in order to make this thing charge, or to remove the neutralness, if that's even a word, from the object, you need to charge it, okay? So you can see the jersey. You take a balloon. The balloon is neutral. The jersey is also neutral. The balloon contains protons and neutrons and electrons, and the jersey also contains protons, neutrons, and electrons. Now, you take these two neutral objects and you go and rub it together, like in the second picture. What happens is the electrons are then transferred from the jersey to the balloon, or from the balloon to the jersey. It depends on which has more electrons and which is more acceptable to donating or accepting electrons, okay? And now the balloon becomes more negative. Now, when you go and take that charged object and you bring it, and you, let's say, like I said, the balloon experiment, you bring it towards water, it's going to deflect the water, because the water is going to be repelled away from the balloon. Water is a dipole molecule, so it's partially negative, partially positive, but those are we learn in chemistry. So that's why when you take a charged balloon and you bring it near water, the water will sort of deflect because of the nature, the dipole nature of water. Okay, so I just wanted us to have a visualization of Coulomb's law and why it is important for us to understand. Okay, then also what I didn't do as well is I didn't sort of put the conversion scale. This is important, okay? We are talking about charge, okay? We are talking about charge objects. We are talking about electrons traveling. And so the conversion scale is very important. Sometimes they will say object 1 is 2 microcoulombs and object 2 is 3 microcoulombs. Calculate the force between the two. You must know that micro is to the -6. They might say nanocoulombs. You must know it's -9. Pico, -12, and milli is -3. Okay, so usually, okay, we mean when we say micro, okay, we mean -6. Or if not the micro, they'll say like a UC, NC, PC, MC. Okay, but you know NC, nano, PC, pico, MC, milli. It's only the microcoulombs that sort of has this U shape. Okay, so that's important. Just keep it at the back of your mind until we get to where we need to solve questions. Okay. Now, what I didn't also speak about was the relationship between Coulomb's law and Newton's law of gravitational of Newton's law of gravity. They are kind of the same, okay? But even in terms of its definition. But the only difference is that Newton deals with masses, Coulomb deals with charges, okay? And Coulomb's law is forces of attraction and forces of repulsion, okay? So Coulomb's law is forces of attraction and its forces of repulsion, whereas Newton's law of gravity is only an attraction law, okay? It only deals with things coming together, okay? It doesn't deal with things being pushed away from each other, okay? So like they're saying here, do not confuse this law. Both product of the quantities are inversely proportional to the square distance, okay? The different constants, obviously Coulomb is K and Newton is G because of gravity, okay? And Coulomb's is attraction and repulsion, and Newton is attraction only, but it's the same, okay? Products of its masses inversely to the square distance between their centers, whereas Coulomb is products of its charges inversely proportional to the square distance between their centers. Okay, so now let's look at some questions. It seems questions are cut out there, but let's look at some questions. Okay, example 1 and example 2 are what we are discussing: the inversely proportional and the directly proportional relationships between these elements in the formula. It's 1 mark, it's 2 marks basically, but it's important because we often, what I've come across a lot is that we often don't understand how to do this and we just ABC D our way through the multiple choice. But if you actually understand it, it's not very difficult, okay? So take a screenshot, pause, write down, okay? So example 1 says, what will the magnitude of the electrostatic force be between two charges Q1 and Q2 when the magnitude of both charges is doubled? So they're asking about the force if we double the charge. So you can see here, we said that force is directly proportional to the charge. So it means force, if I'm doubling the charge, remember Q1 and Q2, they are multiplied together, okay? So I have 2 Q1 and 2 Q2. That makes it 4 altogether, okay? And because it's directly proportional, it's going to increase. So if charge increases, then force will also increase. Easy to understand. Now, if you had maybe not come across something like this, maybe you wouldn't have understood how to answer this question. So they'll give you 4F, 2F, 3F, and 1 and a quarter F. Now you just go and circle anything without really understanding that the answers are actually in the definitions, are actually in the formula. Okay, inversely means if I'm going to increase something, I'm going to double force, I'm double the charge. I'm going to triple the charge, I'm going to triple the force, because these things are directly proportional. Okay, so that is example 1. Then example 2. If charge Q is halved and charge Q2 is 4, and if charge Q1 is halved, and the second charge is 4 times, so it's quadrupled, what will the magnitude of the electrostatic force be? Again, we know that force is directly proportional to the coulombs, basically, right? So there Q1 I halved, okay. Q2 I quadrupled, okay, which means a half multiplied by 4 is 2, which means it's going to be 2F. If I half the one force and I quadruple the other, the force will be increased by 2. Hope that makes sense. Take a minute, just take a minute, take it in, look at it, read the question. Q1 is halved and Q2 is 4 times, or Q2 is quadrupled. What will the magnitude of the force be? I want to know what F will be. I half Q1, I quadruple Q2, I multiply the two numbers together, so half multiplied by 4 is 2, and so the force will increase by 2. Okay, I hope that makes sense. Okay, let's continue. Example 3. Now we dealt with the directly proportional part. Okay, we dealt with the part where force is directly proportional to the coulombs, the charge. Now we're going to deal with inversely proportional. What's the relationship between force and the distance, because they are inversely proportional now. So look at example 3. Example 3 says, if the distance between two charges Q1 and Q2 is halved, what will the force be on each charge? So they said Q1 and Q2 is halved. Okay? what will be the force on each. So if the distance, so if the distance is half. So now R, I'm halving R. And they want to know, if I halve R, what am I going to do to the force? So it's because it's inversely proportional. If the one decreases, we know the other one must increase. That's the inversely proportional relationship. So your answer must be big, because if I'm decreasing R, I am increasing F because of the inversely proportional relationship. Okay, so there a half R squared. Okay, where did the 1/4 come? Obviously it comes from the square. So a half squared is 1/4. So 1 squared is 1, 2 squared is 4. So it's 1/4 times R squared. Okay, and how did they get 4F? You tip and times. This is a tip and times relationship. You can actually, they show you on the computer here. Okay, so you tip and times. So it's going to be 4/1 times R squared, and F will be then 4. So basically you just times 1/4 multiplied by 1, and that will just be multiplied by 1/1, and that will just be 4. Okay, then example 4, also these, remember, these are all multiple choice questions. Okay, these are all multiple choice questions. Example 4, one of the charges doubled and the distance is made a third. What will be the force? So we are doubling one Q, okay, one Q, and we are basically cutting the distance into a third. Okay, so we look here. 2, because it's only one. They said only one charge is doubled, and the distance is going to be a third. So 1/3 to the power of 2 is 1/. So it's going to be 2/9 times Q1 multiplied by Q2 over R squared. Again, you tip and times. This 1/9, you tip and times, it becomes 2 9/1, and it's going to be 18. Or you can put this directly into your calculator, 2/1/9, just with the numbers, okay? And then it will give you 18F. Okay, so you see, if I double the charge and I cut the distance into a third, okay, then it means that my force is going to increase by 18. Okay. Last example, example number 5. 2 charges of the magnitude 6 NC. NC is nanocoulombs, hey? Nanocoulombs. So positive 6 NC and negative 3 NC, so nanocoulombs, are placed 30 millimeters apart. What is the magnitude and the direction of the force acting on the 6 nanocoulomb charge? So first of all, nanocoulombs is times 6 times 10 to the negative 9. And then we have millimeters, but we do not work in millimeters, we work in meters. Okay, remember from the first impulse and momentum session that we did, I said we always have to work in SI units. We never work in millimeters. Okay, we never work in grams, we work in kilograms. Okay, distance, meters, weight, kilograms. Okay, so you have to obviously convert the 30 millimeters over here to meters, so you divide by 1,000. It will be 0.003 squared, or you can just say 30 divided by 1,000 into your calculator. Okay, and we obviously substitute. So we have 9 times 10 to the 9, that's the K constant. 6 times 10 to the negative 9 multiplied by 3 times 10 to the negative 9. And we have an answer of 1.8 times 10 to the negative 4 newtons. Okay, I feel like that's fairly straightforward. We just use Coulomb's law formula. Now, in the next couple of slides, we are going to take Coulomb's law, because we just did normal linear equations, okay? We are going to take Coulomb's law now, and we are going to put it into 3D, sort of. Okay, we're going to have it over a Cartesian plane, and then we are going to solve. Okay, so I hope that the multiple choice questions makes a lot of sense now, that you're able to know what happens when the force is doubled, the distance is doubled, the charge is doubled, what happens with the other components in the equation. All right, so now we're going to do it, not 3 dimensions, sorry, in 2 dimensions. Okay, now we did it in 1 dimension. We just had either x-axis or y-axis only. Now we have an x and a y-axis. Okay, so now we are going to do charges in 2 dimensions. Okay, so obviously have to understand that we are working with two charges over here, okay? They are always going to ask you, and I think we are not unfamiliar to the concept of three-body diagrams or force diagrams for that matter. Okay, so let's look at this charge over here. Charge A, B, and C. We always consider a charge a positive test charge, remember? And then you are given two other charges with different charges on them. One could be negative, one could be positive, okay? Now, from grade 10 already, you were supposed to be taught that we always write head to tail, okay? So it must be head to tail. This over here is not drawn in head to tail. Okay, it's not drawn in head to tail. So please, according to physics rules, you must always draw head to tail. Okay, so here we have A, which is a negative charge, and we have B and C, which are both positive. B obviously is being repelled from A, and C is also being repelled from A. So here, force B on A is going that way, force C on A is going that way, which means the net force would be the hypotenuse. Okay, the net force would be the hypotenuse. Please, that is very important. Okay, now, if you want to calculate the net forces, you must use Pythagoras because here we are working in a triangle and we're assuming that this triangle is 90 degrees, which means we need to work, or we need to assume that we are going to this 90 degrees, and so therefore we are going to use the Pythagoras theorem. Okay, now force C on A plus force B on A, you square that. Remember, Pythagoras says A squared is equal to B plus C squared. Okay, and so the force C on A, you take C and A, you multiply them together. I mean, you add them together, you square it. Force B on A, you use the Coulombs law formula and you square it. Okay, so here they show you F net. Okay, QC, the charge of C multiplied by the charge of A over R squared, that distance, okay? The distance between C and A. Then B and A, you take charge B multiplied by charge A divided by the distance between B and A. Okay, that's very important. Very important. Okay, there's so many ways you could do it. But what we want to get is the resultant force. So we would usually go for this one. You could take net, which we just calculated, minus force C on B, because remember, C and B here are both positive, so they are going to repel. Okay, they are going to repel each other. So these are all the ways you can calculate it, but we generally just go for the normal, A squared is equal to B squared plus C squared. But remember, your resultant force is always going to be the hypotenuse, okay? All right. So let's look at an example, okay? And I think this is an example that we are going to end off with, okay? So this is the example we're going to end off with. So a third sphere, Z, of an unknown negative charge is placed at a distance of 0 meters below sphere Y. In such a way, 0.30 meters below sphere Y. In such a way that the line joining the charged spheres X and T is perpendicular to the line joining the charged spheres Y and Z as shown in the diagram below. Okay, now let's look at this. They gave us a scenario, okay? I cut out the top part because it wasn't important, because everything that they gave you in the description, it's given to you in the picture. So we have two charges and one unknown charge, X, Y, and Z. Okay. Now, X is 6 times 10 to the 6. It's 6 nanocoulombs. Sorry, yeah. 6 negative 6 microcoulombs. Yeah. 6 microcoulombs. Y is 8 microcoulombs, and we don't know what Z is. We don't know what Z is, okay? We know that the distance between sphere X and sphere Y is 0.20 meters, and they are both positive Y because they are both positive Y. How would I know that these are both positive? Because they say it's like charges, okay? So they are basically repelling each other. Okay, and then sphere Y and Z are unlike charges. So they are going to be attracted towards each other. One is positive and the other one is negative. Okay, now let's look at the questions. The first question says, draw a vector diagram showing the direction of the electrostatic force and the net force experienced by charge sphere Y due to the presence of charge sphere X and Z respectively. Draw the vectors first and show the correct direction. So, remember I said when you are drawing, I'm not necessarily talking about the resultant force, hey? I'm talking about when you are connecting your known charges, okay? It must be drawn head to tail. Do you see that it's drawn head to tail? Let's keep it that way. Yeah. It's drawn head to tail, okay? It must be drawn head to tail, okay? So what did we say? X and Y are repelling. Z and Y are attracting, okay? So this would be X on Y, and this would be Z and Y. You see how it's drawn head to tail? Very important. So if net would be your hypotenuse. That's a vector diagram. And so those are your 2 marks in the back. Okay? I hope that is crystal clear. Makes sense to everyone. Okay? Next. Now the next question says the magnitude of the net electric. Now we need to calculate the magnitude of the net electrostatic force experienced by the charge sphere Y is 15.20 newtons. They're telling you F, they're giving you F. Okay? Now they're giving you F. Remember, we always have to calculate F. Now they give you F and they tell you that the net electrostatic force is equal to 15.20 newtons. We want to calculate the charge on sphere X. Typical exam question. Sometimes they're going to ask you to calculate R squared also. Okay. So we first write Coulombs law. Coulombs law. What does Coulombs law say? The electrostatic force between 2 charges is directly proportional to the product of its masses and inversely proportional to the square distance between the centers. So now we have the F net squared is equal to F Z on Y plus X on Y. Either way, you can say Y on X, Y on Z, or Y, X on Y, but just make sure the Z on Y, okay, and Y, X on Z and Y on Z. Okay, so X on Y and Y on Z. There's 3. Okay, so there we go. And they tell you here that the net force is 15.20 newtons. Now what you do, you have the distance between. They want to find, what do they want to find? They want to find Z. So which means you must use, let's go back again. Just want to go back again. So they want to know this distance over here, which means you must, they want to know this, the charge on Z. So X on Y, if net is equal to X on Y squared plus Y on Z squared, and you would have F net, they already gave it to you. They told you that F net is 15.20 newtons, okay? And so how do I know what distance to use? Obviously, you're going to use Y on Z because there's no Z in this plane here, in this horizontal plane. There's only Z in the vertical plane, right? So you're going to use, you have your distance, you have your charge, you're looking for the other charge, and you have your F net. Okay. So there we go. X, Y, and Z. Y you have 8.8 times 10 to the 8 microcoulombs. K, remember, is a constant. You have your F net, okay, and then you're looking for QZ. But just hold on a minute. It says here that Fz on Y is 10.70 newtons. Why 10.70 nutons? Why 10.70 newtons? Because you are going to take 15.20 newtons squared is equal to, remember, A squared plus B squared is equal to C squared, right? Okay, so if Z on Y is what you are looking for, because that's the charge that you are looking for, okay? And then you have 10.82 newtons. This was given to you also, okay? So what you do is now the F net is actually this, because you already did A squared plus B squared plus C squared, okay? They told you that the force is 15.20 newtons. They didn't tell you that F net is 15.20 newtons, okay? So once you have F net, You are then going to multiply the K constant by Q1, okay? And then you have QZ you are looking for and 0.3 squared. Now you use basic algebra, okay? You will use basic algebra and then you will solve for QZ. Sometimes you will also have to solve for R squared, okay? So these set of questions that I've given you now is what is it's basically what the exam is going to be about. Sometimes you're going to have to look for force, and that's easy because you have K, Q1, Q2, and R. Sometimes you must look for Q1 or Q2, and sometimes you must look for R squared. Okay, so that brings me to the end of the session. But before I end off, there's just two things I wanted to mention. Number one is that please pay attention to the units that they are giving you. That's number one. Please pay attention to the units that they are giving you. It is extremely important. And also make sure that you write, so you can't just say 1.34 times 10 to the negative 5. It must be coulombs, okay? If you're measuring force, it must be newtons. If you're measuring mass, it must be kilograms. Distance, meters, okay? Because in physics, we need these things, they mean something, okay? They mean something. They have physical representations. Okay, number two, read the question. When they're asking you, calculate the magnitude, then they are looking technically for newtons, okay? If they say calculate the net electrostatic force, then it means they are looking for coulombs. Calculate the distance between the two forces, then they are looking for the radius, okay? Or the radius squared, okay? So those are very, very important. Please read the question. My teacher used to say that the question is the answer is in the question, and that is true. The things that they are giving you, it's already there. You just need to be able to dissect it, okay? And with enough practice, inshallah, I'm sure all of you will manage to do so. Okay, and so from me, this is the end. I will see you hopefully tomorrow, inshallah, with a new topic on work energy theorem. Assalamu alaikum wa rahmatullahi wa barakatuh.
Wa alaikum salam wa rahmatullah. We say shukran, jazakallah khair, and baita makasi to our sister Zainab Afrika from Supreme Scholar, who so beautifully facilitated today's session on content for physics paper 1 dealing with electrostatics specifically. I hope that all of our beloved viewers to the Voice of the Cape's Facebook page and YouTube page have benefited greatly from this course. And as a reminder, once again, in conclusion, please, all of our viewers, if you know of matriculants in your family, in the community, share and forward this link to them as they prepare for their upcoming NSC exams and as they continue with their trial exams. And as a reminder, this is the Voice of the Cape's annual online matric revision program. For this year, 2024, our main sponsor is the Two Oceans Graduate Institute, which is an accredited online platform where you can become a primary or a high school teacher by studying in the privacy of your own home. If you'd like to find out more information, you may contact them on the number 021 829 7015, or you may visit their website www.togi.ac.za. On behalf of myself, Amir Adams, and everyone here at the Voice of the Cape, we wish all of our matriculants all of the very best as they prepare for the NSC exams, main exams, inshallah, in their schooling career. And we wish you everything of the very best as you continue with your trial exams as well. And we also would like to once again say shukran and thank you very much to our esteemed facilitator, Sister Zainab Afrika, on behalf of Supreme Scholar, who's doing great work, alhamdulillah, and of course assisting our matriculant students. May Allah Almighty reward you and bless us all, inshallah. On behalf of our side here at the Voice of the Cape, we say shukran, jazakallah khair, and wassalamu alaikum wa rahmatullah.